Hello, welcome to another episode of That Mathematician, starring your very own Sahil Garayan and my co-host Nugget. Yes, he's a dog. Today we are going to be discussing Isaac Barrow. I was just reading about the gentleman. He is a mighty fine gentleman. Isaac Barrow was born in London, England in the 1630s, and later on he eventually died on May 4th, 1677. But that is not important. What is important is what he did for the world of math. He first went to the University of Cambridge in 1643, graduated with a bachelor's in 1648, later with a master's in 1652, and eventually started teaching at the school. Now, he mostly learned his mathematics during the 3 years he was studying abroad between those times, from places like Paris, Florence, Germany, Netherlands, places in the European continent. Now, during this time, he had a small child with him that would attend his lectures from 1664 to about 1665. His name was Sir Isaac Newton. Now, the reason why Sir Isaac Newton knows everything about math and calculus is because of Isaac Barrow. I do not care what anyone else says. People say that Sir Isaac Newton is number one and Barrow is second to him. To me, it's vice versa. You okay? Okay. It's vice versa. Why? Because he was the first one who implemented everything about math and the fundamental of math. Now, during this time, whenever he noticed that Sir Isaac Newton was going to be someone of a great mathematician, he decided to give up his role and his post at the University of Cambridge to Mr. Newton, where he ended up taking his role as a mathematician at the university. Now, after he left the university, he went to the Holy Trinity of London, where he became a fellow, just like me, and further continued his studies of mathematics to the church. Alright guys, one of the other things that Isaac Barrow did was he came out with the fundamental theorem of calculus. What I have over here is Barrow's fundamental theorem, which states that if f is continuous on a to b, then the function g defined by g of x equals the interval from a to x, f of t dt, is continuous on the closed interval ab and differentiable on the open interval ab, and g prime x equals f of x. Now, obviously, this does not state that because the people back in the day would only use letters and nothing else, so this would be very difficult to help you guys understand. But in the 21st century, we've made things kind of simpler. So this states that if x and x plus h are in the closed interval ab that we had stated previously up here, if we take g times x plus h minus g of x from the interval a to x plus h f of t dt minus the interval from a to x f of t dt, that will equal the interval from a to x f of t dt plus the interval from x to x plus h f of t dt minus the interval from a to x f of t dt. Obviously, what happens if we have two same bases? The answer will be the interval from x to x plus h f of t dt. And so if we make h if we make h not, this is not equal 0, we have g of x, x plus h minus g of x all over h equals 1 over h from the interval x to x plus h f of dt. For now, let's assume that h is greater than 0. Okay? Since f is continuous on the closed interval x and x plus h, the extreme value theorem says that there are numbers u and v in the closed interval x and x plus h such that f of u equals m and f of v equals capital M. Now, by property 8, if you guys remember of the integrals, we have lowercase mh is less than or equal to the interval of x plus h f of t dt, which is less than capital M lowercase h. That is only if f of u times h is greater than is less than or equal to the interval from x to x plus h f of t dt, which is less than f of v times h. Now, since h is 0, we can divide this inequality by h. So when we divide this inequality by h, we can use equation 2, which is right here, to replace the middle part of this inequality, which we have done so right here. So inequality 3, which is this, it can be proved in a similar manner for the case where h is greater than 0, but that's for another exercise. But let's continue the theorem. So as we continue the theorem, let's have h go to 0, then we'll have u go to v, and then we'll have v go to x. Since u and v lie between x and x plus h, therefore we have the limit as h approaches 0, f of u equals the limit as u approaches x f of u, which equals f of x. Also, and we have the limit as h approaches 0 f of v equals the limit as v approaches x f of v, v approaches x f of v equals f of x. If x equals a or b, then equation number 4, which is this right here, can be interpreted as a one-sided limit. Then the theorem shows that g is continuous on AB. So using Leibniz is probably one of the other mathematicians which will later be discussed. He uses the notation for derivatives, We could write the fundamental theorem of calculus part 1 as d over dx from the interval a to x, f of t dt equals indeed f of x. Now, there is a review question that you guys have to answer based off of this. So I want you guys to find the derivative of the function. Capital F of x equals the integral from 0 to x, t squared over 1 plus t to the power of 3 dt. Now, if you guys have any questions, and obviously you cannot ask him, but you are more than you are more than welcome to ask me, because Isaac Barrow is dead and he won't be able to help you. Yes, I know, so sad. Regardless of the fact, Dr. Murray should be able to help you, but I highly doubt she'll help you because this question is probably the easiest question you could answer. You okay? Okay, I think our co-host is getting a little weary, or he's already kind of drunk. But regardless of the fact, I hope you guys have a wonderful rest of your day. To all the kids in the class, good luck to your finals, and I wish you guys nothing but the best in life, and so does my co-host Nugget. Thank you very much.